Okay, so in the previous video, we found out what to do if we had a power of if the power was a fraction of the form 1 over n. And basically we figured out that whatever n was, that was going to be the root that you would take of the number. But what about if the numerator is not 1? What about if our fraction was m over n instead? Well, what we do is we use the brackets law in reverse. Now from earlier on, we know that a to the power of b to the power of c is a to the power of bc, two things being multiplied together. So for this first one, we're going to look at 3 over 2, and we're going to think what 3 over 2 is equal to. Well, 3 over 2 is equal to a half multiplied by 3. So I think we can rewrite 25 to the power of 3 over 2. Using this bracket law in reverse, we can write it with some brackets. I think we could do 25 to the power of a half times, with to the power of 3, because the half times the 3 is the thing that will give us the 3 over 2. So what we need to do now is think what this part means. Well, 25 to the power of a half, you might not need to write this, it means the square root of 25. So I'm going to try and evaluate this now. The square root of 25 is 5, so it's going to be 5 cubed, and 5 cubed is 5 times 5 times 5, which is 125. So now we've started looking at one with an example where it has got a fraction where it's not a 1 on the numerator. And I'll show you it's true. If I do 25 to the power of 3 over 2, 3 over 2, we do get the answer 125 on the calculator. So I guess in general, if we have a fraction m over n, if we had a to the m over n, whoops, not over 2, we can do the nth root of a to the power of m. Now, I don't think I would memorize this, but you might like to add that to your notes. But it's this sort of law in reverse and using the fact that the 1 over n is the thing that gives us the root. So let's try this 16 to the 5 over 4. Well, we know that 5 over 4 is going to be 5 multiplied by a quarter. 5 quarters is 5 times 1 quarter. So I'm always going to go for doing the rooting part first. So we'll do the 16 to the quarter to the power of 5. Now the 16 to the quarter, you might not need to do this part, but it's the 4th root of 16, and that's all going to be done to the power of 5. Now the 4th root of 16, we actually did that earlier. The 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. So that is 2 to the power of 5. And 2 to the power of 5, 2 times 2 times 2 times 2 times 2 is 32. So 16 to the power of 5 over 4 is indeed 32. So I'm going to do a few more examples here, and then you're going to have a go at doing these 4. So I'm going to try these ones down here. Now 64 to the power of 2/3. I'll do that as 64 to the power of a third, and then I'm going to square the answer. Now 64 to the power of a third, that's the cube root of 64. The cube root of 64, something times something times something equals 64. The answer is 4. 4 times 4 is 16, and times that by 4 and you get 64. So it is 4 squared, and so the answer is 16. 32 to the power of a fifth. Now, if you wanted to, you could do 32 squared and then do it to the power of a fifth. But trying to find the 5th root of 32 squared, which is not an easy number to deal with, 32 squared, 32 times 32, trying to find the 5th root of 1024 is not going to be very easy. So instead of doing it that way around, we're always going to do the rooting part first. We're going to do the 32 to the 5th, and then we're going to square that. So that's the 5th root of 32 being squared. Well, the 5th root of 32 is 2. 2 times 2 times 2 times 2 times 2 is 32. So it's 2 squared, which is 4. Let's check this out. So we're going to do 32 to the power of 2 over 5. It is indeed 4. So this one, the 0.6, let's just change it to a fraction. 0.6 is 3/5. So I'm going to split it into the 32 to the power of a fifth and then to the power of 3. Well, we know that 32 to the power of a fifth is just 2. So it's 2 cubed, which is 8. We know it's 2 because we just looked at it over here. Now, 9 to the power of 2.5. 2.5, we need to put that as a fraction. 2.5 is 5 halves, because you've got 4 halves for the 2 and then the extra half. So it's 9 to the power of 5 over 2. We'll do the 1 over part first. 9 to the power of a half to the power of 5. That's the square root of 9 to the power of 5. That's 3 to the power of 5. So that's 3 times 3 times 3 times 3 times 3. Okay, well that's a 9 times 9. That's 81. So it's 81 times by 3. And 81 times 3, that's going to be 243. So 9 to the power of 2.5 is 243. So there's 4 questions here for you to have a go at. Pause the video and try them, and then I'll go through them in just a second. Okay, so 81 to the 3/4. We're going to do the 81 to the quarter first of all, and then we'll cube it. So the 4th root of 81 cubed, well the 4th root of 81 is 3. So we're doing 3 cubed, and 3 cubed is 27. So I'm going to do 1,000 for this one to the power of 1/3 and then squared. Now I'm not going to do this extra line that I've been doing like here. I'm going to go straight to it. The cube root of 1,000 is just 10. So it's just 10 squared, which is 100. Now 32 to the 0.8, that's actually 32 to the 4/5. So it's very similar to a question on the other page. So I'm going to be doing 32 to the power of 1/5, and then I'm going to be doing it to the power of 4. 32 to the power of 1/5 is 2, it's the 5th root. 2 to the power of 4, 2 times 2 times 2 times 2 is 16. Now this last one, 100 to the 3.5, that's 100 to the 7/2. 3.5 is equivalent to 7/2. So it's going to be 100 to the half to the power of 7. 100 to the power of 1/2, that's the square root of 100, which is just 10. So it's 10 to the power of 7, which is luckily very easy. There's going to be 1, 2, 3, 4, 5, 6, 7 zeros, meaning it is 10 million. Let's just double check that last one. We'll do 100 to the power of 3.5. Yep, there's 7 zeros there. It is 10 million. Okay, so in the next video, we're going to think, what about if the base is fractional? You'll notice here in my blue questions, the base is always an integer. Let's try and see what happens if the base is fractional. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.